So all the homework problems are going to come out of the same two sections. We didn't do any of the solved equations. Now we'll go back and do the solved equations. And then next class we're going to take a quiz over factoring. Right? Not the solving equations part, but the factoring stuff we did yesterday. And there will be another quiz in the chapter, and it'll also have some factoring in there too. Just because factoring is that important. We need to hit it a bunch of times to make sure we get it. Okay. So there's many ways to solve quadratic equations, right? By a quadratic equation, we mean something like ax squared plus bx plus c equals 0. Right? And most of the time, we kind of expect it to be in that form, meaning we start with standard form equals 0, and then we go from there. So today what we're going to look at is this solve by factoring. Taking square roots is a method that we'll do next. You take square roots, mostly the way it's taught is if there's no middle term, then you really can't isolate all the x's in one term. You can isolate the x squared and then take the square root of those. Graphing, we'll learn about that a little more in the class today, but definitely you want to have, before you graph, you've got to have things in that standard form. Completing the square is sometimes not really used as a way to solve equations. If it is used as a way to solve equations, it's kind of actually like taking square roots. It's a special case of that. But completing the square is a process that will come up many times in, if not this class, it comes up here mostly. In math analysis, it comes up in a few places. In calculus, it comes up in a few places. It's not that hard. It's no harder than doing that. But a lot of times we don't master that like we should. And the thing about completing the square, and actually the only part of completing the square we're required to know by the SLL, is that you complete the square to derive the quadratic formula. So when you use quadratic formula, you're really kind of using a completing the square process. And to use the quadratic formula, it's got to be in that form too. Standard form equals 0. The solutions to quadratic equations are called roots. So we'll see that there's actually a few different words that get thrown around for that, and sometimes they're not used very consistently. But this book seems to be presenting this right up front in a good way, which is just to say, when you solve equations, you're finding the roots of the equation. So methods to solve. So we solve by factoring by using what's called zero product property. And the zero product property is like a converse, if you remember your logic from geometry, right? You have a statement and you've got an inverse and a converse and a contrapositive and all that stuff. It's the converse of the property, the multiplication property of 0, which just tells you anything times 0 is 0. Which if you go backwards on that, I would say if you multiply two things times 0, that tells you that you must have started with a 0. There's no other way to make a 0 through multiplication other than you started with a factor that was 0. So there's an example, right? If this product equals 0, then one of the factors has to be 0. So you set both factors equal to 0 and solve. That's the principle of zero product property. In the last book I taught out of, they called it the zero factor property. But that's the only time I've ever seen it called that. Okay. Let me know if I go too fast. So here they say, what are the roots of the equation? it's asking for, what are the solutions? Solve for x. And again, we can't solve for x in the traditional methods that we've used up till now, because x is in two different terms and they're not like terms. So that's what we factor. And that's a pretty easy factoring problem, isn't it?
It is.
What are the factors of negative 36 that add up to negative 5? 9 and 4, but one's got to be positive and one's got to be negative. Negative 9, positive 4. So we get x minus 9, x plus 4 equals 0. Okay. So now we know that one of those factors has to be 0 if the product is 0. So we'll set both of them equal to 0 and solve. X minus 9 equals 0, and x plus 4 equals 0. So x equals 9, or x equals negative 4. That's it. I'd say most of the time when you're factoring like this, you don't, especially in a class, this is a medium-high class, learning fairly sophisticated stuff. You may not show that little step right there for x minus 9 equals 0. You probably just right there say the answer is 9 and negative 4. And you can see that. So it's okay to just say x is 9, x is negative 4. Now, one thing that we'll get to more, but this is just as good a place as any to point it out, that if 9 is a root, then x minus 9 is a linear factor. It's linear because it's x. So whenever you solve for the roots, then you know that x minus that number is the factor. So I think this is one for you. Solve. So how did it factor? Kim? X minus 7, x plus 6 equals 0. So again, I can set this up. X minus 7 equals 0, and x plus 6 equals 0. Or even right here, I can just say x equals 7, x equals negative 6. Done. Right. For a simple linear factor, which has got a 1 as a coefficient, you can see it immediately. Okay, the next is, now we talk about the relationship between quadratic functions and quadratic equations, right? Remember that a function has a y in it, right? It's y as a function of x. You have studied this before a little, right? You remember that the shape of the graph of a quadratic function is a parabola. And a parabola has the shape of a U, right? The U could be opening up, or the U could be opening down, right? If the A, the coefficient on x squared, is positive, you know that it opens up. If the A is negative, you know that it opens down. Right? You know that the C, the constant term, that's the y-intercept. Right? And the roots of the equation, meaning the roots of the equation 0 equals ax squared plus bx plus c, are the x-intercepts of the graph. And those are called zeros. So the word zeros is really referring to, it's the same thing as the roots of the equation are the zeros of the function. A lot of times I think we use the word zeros when we really mean roots, or maybe we use roots when we really mean zeros. But in the end, to us, it's really about the same thing. It's x-intercepts, it's solutions, it's roots, it's zeros. They all basically refer to the same thing. Yeah. The dx? Yeah. There's nothing about the dx in this. Yeah. No, the A and the C definitely. Again, remember a quadratic equation, the one that we always looked at was like this. 0 equals
ax squared plus bx plus c. So really, the quadratic equation is just the special case of the quadratic function where y equals 0. Where does y equal 0 on a graph?
Or on the
x-axis, right? In the xy plane, right? On the x-axis, y equals 0. So really what you're finding when you find the solutions to the equation, you're finding the x-intercepts of the graph right there. So, we will be able to, by factoring the quadratic expression on the right side of a function, we'll already know the y-intercept, we'll already know whether it opens up or down, and we'll be able to find the zeros for x-intercepts. So that's a fair amount of information to know. So, and the one thing about the way they say this in this book, which I don't like, is that it says find the zeros of the function by rewriting the function in intercept form. I think what they're calling intercept form, I would call factored form. But again, what do you find from it? You find the x-intercept. So I understand where they come from with that, but usually I'm thinking standard form, factored form, standard form, factored form. So when you do the homework, don't be confused by it. They're using the same language in the homework as they are in this example. So we're finding the zeros of the function, essentially. So, and how are we going to do it? Factoring, that's all we're doing right now. How does this letter A factor? X minus 4, x plus 3, right? So the zeros are x equals 4. Yeah, and negative 3. Now, you shouldn't be confused if they present it like this. 4, comma 0, negative 3, comma 0. Yeah, the y-coordinate is 0, so that's fair. How about the next one? What are the factors of 36 that add up to 12? Y equals x plus 6 squared. So the 0 is negative 6. I should say that's x equals negative 6. Now, I'm going to go ahead and say things that maybe they will come up later, but this is just as good a place to show this as any. There's a difference between the graphs of these two. They're both quadratics. They both have the same shape. They both have a positive A, so they're opening up. You can see what the y-intercepts are. The one on the right it only has 1, 0, because the graph actually touches negative 6 and then goes back the same direction. This one has zeros at negative 3 and 4. So that means it goes through and up like this. Right. When you find a 0 that comes from a squared factor, that's always what it looks like on the graph. It touches the axis and it goes back the same way. If you find zeros where the graph goes straight through the 0, that means it's coming from a factor which is to the first power.
Two arrow go down.
What's that?
I saw like there was like two arrow go down. What is it? What does it look like on the?
I'm not sure what you're saying.
Like, you know how like that two arrows go up?
Okay.
Yeah, but what happened if like two arrows go down? What situation?
If this was a negative x squared, then it'd be going down.
Okay.
That's what makes it go up or down, the leading coefficient, if it's positive or negative. Okay, so you go ahead, find the zeros of those. It's really the same process you just went through to find the roots of the equation. Now you're finding the zeros of the function, but you're doing the same thing.
Do you have a question?
No, just find the zero. So how does the first one factor? The factors of negative 14 that add up to positive 5.
Negative 2.
Yeah. edit, undo. X plus 7, x minus 2. Okay, but the zeros are x equals negative 7, positive 2. Because it's whatever you plug into the factor to make that factor 0. Yeah.
Does it matter which side, negative 7 2 is?
You write x minus 2 times x plus 7, commutative property, right? Doesn't make any difference. How about the next one? What's the factoring? Negative 10, positive 3. So the zeros are x equals 10 and negative 3. And the last one, now they're using a function notation, f of x equals, factor it, x minus 5 squared. It's a perfect square trinomial, and so it has 1 0, which is 5, which tells us that the parabola is going to come down and touch the graph at x equals 5 and go back the same way. Okay, spot the errors. And then
What did they do wrong on this side?
Negative 2.
It should have been negative 3, positive 2. Okay, I think you have the pluses and minuses switched up. How about the number 40? What did they do wrong?
It's not a zero.
Sean?
It's not a zero.
They don't have 0 on the other side, right? So they have this set equal to 14, and they've got it in factored form. It's like they've got a 14 product property. We don't have such thing. We've got 1, 0 product property. So you can't take this and say, well, that means x plus 6 equals 14 or x plus 1 equals 14. It does not work that way. You have to have a 0 on the right.
So that 14 shouldn't even be there.
No, but if you get a problem like this, you first subtract 14.
Oh,
So you do have a 0, and then that one's actually factorable.
okay. I see.
we're going to have 1 or 2 more like that. But this one, if you subtracted 8 from both sides, it would have been x squared plus 7x minus 8 equals 0. So actually there are factors of negative 8 that have positive 7. So it was solvable, but not like that. And so now we're going to solve an equation that requires the more complicated kind of quadratic trinomial factoring. So I think maybe it's good as time to stop. We'll wait till we come back to finish it. I think we only have about 3 slides left to go. Okay, so now we're going to solve an equation, find the roots, and we're going to have to do the not simple factoring. So let's see. 3 times negative 8 is negative 24. What are the factors of negative 24 that add up to 10? No. 1 positive, 1 negative, so they're adding against each other. 12 and 2, right? So which is bigger? So it should be negative 2, positive 12. So I'm going to split it up. 3x squared minus 2x plus 12x minus 8 equals 0. Notice that I made the negative term first, so that now I've got a plus in between parentheses. I don't have to worry about changing the sign of any terms. Group and then factor. What's the greatest common factor between 3x squared and 2x? X. So that's 3x minus 2. What's the greatest common factor between 12x and 8? Plus 4 times 3x minus 2. And because I did everything right, I got the same thing in parentheses, so I can factor that out, and I'm left with x plus 4 times 3x minus 2 equals 0. Now, we're not done, because it's not we weren't asked to factor, we were asked to solve by factoring. So now we got to say, what does x equal? And from the x plus 4 by inspection, you're going to get that one right away, right? X equals -4. Now, the other one, because the coefficient of x is not 1, you either have to just think a little harder or maybe set it up as an equation to solve, right? The first one was -4. And if you need to, you can say 3x minus 2 equals 0, add 2, and divide by 3. Right, but don't just jump on it and say 2. Right? It's not going to be like that. I think I was telling you the other day, maybe, but when I was learning this stuff and I was your age, if we got to that kind of equation and we had to solve it, we would just put it in the quadratic formula. We wouldn't have been messing around doing all those steps. You know, either you can solve it, you can factor it like really easily, or just put it in the quadratic formula. And eventually we'll get to that.
Why do they change math like that?
What's that?
The way they do that. Why do they change math like that? You said you would just put it in the quadratic formula.
I don't know. I don't know why they changed that up and made us do more factoring. But I mean, some things maybe have some reason because of technology or something, but this I can't really see it. And it's not a bad thing to know. And maybe I just don't remember it so much. But all I remember is you can solve any quadratic equation with a quadratic formula. So to me, it's like, well, why bother knowing a lot else? Especially for you guys, you don't have to memorize a quadratic formula. It's given to you. So as long as you know how to use it, you can solve anything, right? Any quadratic equation. Okay, so there's one example, which is something that is a little more complicated factoring, but still works the same. Now, the next one, what's different about that one? Besides the fact that it may be more complicated factoring. It's not equal to 0, right? So you need to make it equal to 0. So one way or the other, get all terms on one side, 0 on the other. And, you know, in this case, I'm going to subtract 4p and add 5 on both sides, or at the same time in one step. So subtract 4p and add 5. And now I've got 5p squared minus 20. This is going to work out really well. Plus 20. Okay, do I have to do the complicated factoring now? I'm not sure, but there's something I can do first. Factor out of 5, right? In fact, I could factor out of 5, right? I could go like this: 5 times p squared minus 4p plus 4 equals 0. But in the end, the 5 is going to go away, right? So if instead, because this is an equation which you can deal with on both sides, you could just divide out a 5 and not even think of it as factoring. You know, you don't have to carry along a 5, which isn't going to be a part of the solution anyways. But let's say, and then what's left in parentheses now, that's an easy factor. What is that? 5 times p minus 2 squared. Done. And now what's the solution? So the answer is, the root is 2. And I left the 5 in there just because sometimes when we have a constant in there, students get confused about it and they want to say something like maybe 5 is a solution of that. But it's not. Remember, the zero product property says when you multiply things together and get a 0, that means something you started with was a 0. 5 was not a 0 to start with, right? We know that right up front. And so in any case, you could have just divided it out. That didn't work. Undo. There we go. You could have just divided it out and been done with it, because 0 over 5 is 0 anyways. So p equals 2. So here's your first U try. Solve that.
What? Are you talking fast about me?
You got a problem.
Wow, card.
You got a problem. What are you gonna do?
Well, that's right.
Yeah, you go. Why did you?
Hey.
Oh, really?
Trying to concentrate.
You're right.
And if you can't see the 7/2 coming out of there, then you can make the equation and solve it, right? But, you know, all you have to imagine is, you know that 2x has to equal 7, so then you subtract it. Or else just imagine, you need something in the denominator that'll cancel that 2.
Open your eyes.
And then you need something in the numerator that'll cancel the 7.
Got it.
Oh, so three just like this.
Yeah, again, what happened to the 3? Yeah, it's, you know, you can divide, you could take a step and show you divide it out, but it's not part of the solution. I mean, you could have just like at this first step, you could have just shown divide by 3, divide by 3, divide by 3, divide by 3. You know. No, only 4 times, Sean. Try that one.
Just wait and see. That's what you're gonna do.
I mean, I have an answer.
Yeah, you could get it wrong.
Oh,
Negative 1, negative 1.
I know, the first part is right, the second part's not.
How'd you get the first?
It's wrong. Yes, I'm stupid. Okay, so. I just can read.
It's just not stupid.
You're just more smart than other areas.
True, I just really suck at math.
So this is
one that,
Oh.
you know, when you get down to this here, yeah, you can go through the 6-step process. Quiet, please. Sean. Or, Sean, you know, if you add one more thing, then you can add a detention too, okay? Okay, understand. I'm here every day after school. It costs me nothing. These only have 2 factors, right? I mean, so it'd be pretty easy just to guess and check. I mean, it has to be start with a 2x and an x, and then it's got to be either a +1 here and a -1 there, or the other way around, right? You could probably guess and check this one pretty easily. Which way was it? I think it was +1, -1. Yeah.
+1, -1. So x equals, again, if you have to set that equal to 0 and solve, or if you can visualize it, that's -1/2 and 1. And that is it. How about do your homework?
What's SOL?
What is SOL? That's the number of the SOL this stuff supports.
Oh.